Hey there! So welcome to our very first math lesson. Now this lesson is called plugging in. Now plugging in is an alternate way to address all the algebra problems that tend to come up on the test. And sometimes, actually pretty much every time, it's the better way, the faster way, the more accurate way of navigating the algebra problem. So if you happen to forget an algebra concept and just think you're going to freeze up on it, there's basically another way to do it. Now, keep in mind that this is going to be a very unusual strategy. It's not something that you learn in math class. It actually feels really odd when you're working through it. But bear with me. This is going to be something that you need to practice, which is why it's one of the first lessons, so that we have the entire duration of this course to keep practicing this strategy for homework, for drills, whatever it might be. Right? So bottom line, this is going to feel unusual, and there will be problems, particularly in the homework, where you think, you know what, I think I'd rather use algebra. It's going to be faster. Don't. Just for the sake of this homework, for the sake of this strategy, use the plugging in method. Now, what is the plugging in method? Well, let's take a look.
All right, so plugging in. Now, let's dive right into it with this concept. So plugging in general, it is pretty much used when you see variables in the question, variables in the answer choices. And we are going to do a couple of problems together, and the notes for this are actually in a PDF form, so you don't have to worry about scrambling to copy all of this down. It is actually more important that you take the time to understand this concept and try out some of the problems that we're going to be working on, instead of scrambling to just simply take notes. And remember, you have access to this video, so you can watch it over and over again. And you can always increase the playback speed, and that way it doesn't take the full time to watch the video again. Right, so with that said, so identification, now plugging in problems, if you see variables in the question, variables in the answer choices, then that's a definite plug-in problem. Now, an example of this, well, let's take a look at number 2. We'll be working on this, but in this case, notice that it says each side of a square with side x. So we have a variable right here, and it's lengthened, something's happening to that. Which of the following represents, and notice all of the answer choices have variable in it. So this by default, yes, can it be done algebraically? Of course. Every single one of these plugging in problems can be done algebraically, but that's not the point. The point is to make this faster and still basically get the right answer faster, right? So with that said, that's number one of the first ways of when to use a plugging in problem. Another time you use a plugging in problem is when you are missing an original number. So to give you an example, we are going to be working on this problem. And notice what happened. So Anna spilled 1/3 of her M&Ms, and this dude ate 1/5. Then he gave half of what remained. What fractional portion did this dude eat? Well, notice what we don't have. We do not have an original number. We don't know how many we started with in the first place. So in a situation like this, or even in a percentage issue where maybe a store has a discount running and everything is like, let's say 20% off, and then someone has a coupon for an additional 15% off. Well, what fractional part of the original did this person end up paying? That is also a plugging in problem. So fractions, percentages, even if it's not fractions, percentages, just different situations where you're just missing the original number, but you're given the relationships in between, that is a good plugging in scenario as well. So with that said, jump back. Okay, so with that said, what is the approach? Well, first off, keep it simple. We're not trying to come up with this really complicated number. There are no awards for coming up with a complicated number, okay? So keep it simple. It's a multiple choice test. The only thing that the test makers care about is that you bubbled in the right answer. Or at least in the multiple choice section, I should probably put a little disclaimer there. There is that free response section, but either way, point is you put in the right answer, not what your process was. What are good numbers to plug in? 2, 3, 5, 10. And if it's based on percentages, then 100. Those are all great numbers to plug in. It keeps your math simple, especially on a no calculator section, so you don't actually have to worry about it. Never plug in 0 or 1. Why? Simply because any number times 0 is 0, and you can't divide by 0 in case that becomes a necessary step along the way in the problem. And 1 times any number is that original number, and that doesn't really, you don't get to see a clear-cut chain reaction of what number had which impact and how did it basically travel. So bottom line, it's better if you just avoid using the numbers 0 and 1. No repetition. So if you happen to have either numbers that are already given to you in the problem or you happen to have multiple variables, do not use the same numbers that already exist. That means if it's already in the problem, so let's say 2 is already in the problem in some format, well then don't plug in 2. And if you, let's say, had x and y as both of your variables, and then don't plug in 2 or 10 for both of them. Pick different numbers every time. This goes back to the point of how we don't plug in for one, which is that you just need to be able to see a clear-cut chain reaction of what number has which impact. That way, if you need to change anything along the way, it's a little more obvious which number needs to be changed, and you can continue with your math, and it's just faster. All right, so factors and multiples are always awesome, particularly when we're dealing with fractions, particularly when we're dealing with just, honestly, fractions are the best way. Yeah, just they help keep us in the realm of whole numbers, so we don't really have to deal with fractions as much. Again, a huge benefit when we have a no calculator section that we're working on. So that's just something to keep in mind. Now, complete the arithmetic uses. So the first step was picking a number. Now, the second step is to then pretend that that number was there all along. So the variables didn't exist. It was this number to begin with, and just follow through with the math. Once you follow through with the math, circle your final answer. We're just going to call this your finale. And when we say that, you're actually going to box that answer and put a little F next to it. Like that's your final answer. That's what you want as your output. And we'll talk about this in a bit as to what that actually means and put it into practice. Finally, once you have all your finale and everything, you are going to check every single answer choice to see which one gets you to that finale. So if it doesn't get you to that finale, then that's clearly eliminated. But it's important to check every single answer because we just so may have picked that number or that combo of number that validates 2 answer choices instead of 1. Now, this situation is rare, and it's kind of one of the minor downsides of using the plugging in method. But like I said, situation is very rare, but this is just to basically cover our butts and make sure that we are on the right track and we ended up picking the right answer. So let's put that into practice. All right, so going back to some of the math basics that we covered in a previous video, remember that we are still underlining in the problem. We are still basically interacting with the text as much as possible. We are using the space that we've been provided, and I tried to leave quite a bit of space there just so we can do our work together. But it's all to ensure that we are showing our work clearly, and it's not even just about showing your work, it's showing your work neatly, because remember, and I cannot emphasize this enough, and I'm going to keep saying it, this is a timed test, and in a timed test, we are more likely to make small mistakes that we would normally avoid. Something that we are super confident on could now turn out to be a small mistake along the way, right? So it's very important to keep your work nice, organized, and very systematic, just so if you need to ever go back to it and say, oh shit, I have an answer that doesn't match the answer choices, well, you can follow your work and it wouldn't take you as long to figure out where you might have messed up. All right, so with that said, let's work on this problem. Now, in this case, what are keywords? So if C and D are positive integers such that C plus D equals 12, then what is the value of C minus 12 divided by 4C? Okay, just testing out the pen and it seems to be working. All right, so in this case, do a couple of things. So first, let's actually pull up the steps that we need. So these are the steps that we covered in the very last slide. First thing we need to do, well, before we actually replace the variables and everything, is just identify what are the key components of this particular section or particular question. So we have C and D, and they're positive integers. That is important because definitions review. So what is a positive integer? Well, a positive integer is basically, well, I should say positive, we kind of already know, but integer is a whole number. So we need whole numbers only. Okay, no fractions, no decimals, nothing like that. Such that C plus D is 12, what is the value of that? All right, C plus this right here, it's our boundary. Now, when we're plugging in, it's not always going to be this free-for-all, plug in whatever number you want. Sometimes, most times, the question will give you some sort of limitations to stay within. They're not going to be complicated, but it will put a little damper limitations on just what numbers we can pick. So in this case, C plus D have to equal 12. All right, let's pick two numbers that will add up to 12. So let's say C can be 10 and D can be 2. All right, and so that takes care of replacing our variables and numbers. Then complete the arithmetic. So the arithmetic is, this is what the question is actually asking. It's saying, can you solve that equation? Sure, we can. All right, now we have 10 minus 12 over 4 times 2. That is going to be negative 2. This is going to be 8. Reduce it, will be negative 1 over 4. This is our final answer. And because this is one of those exceptions in plugging in, that's not an exception, it's just another type of plugging in where you just have a whole number as your final solution. This is our answer right here. Okay, now I'm going to do something different just to prove a point. All right, and the point I want to prove is that you could have plugged in any number as long as you stuck to that criteria. So let's say this time we picked 10 and 2, right? Now I'm going to clear everything, and we're going to try this again with a different number. So again, positive integers is important, particularly the integer part. So these are two separate things, and we need that answered. This is our criteria. So now I'm going to say, you know what? Let's do 4, and this one we'll do 8. They still add up to 12. Now they're just different numbers, and we still follow through with the math. So 4 minus 12 divided by 4 times 8. Right? This is going to be negative 8. This is going to be 20. Sorry, that was a mistake. It's going to be 32. It's going to be 32. All right, then reduce that. We still get negative 1 over 4. So no matter what numbers you pick, as long as you stay within that criteria, it doesn't matter. You are ultimately still going to get the same answer every single time. All right? Circle our finale, and all of that. A couple other points I want to make sure you know. Always keep track of your variables and always keep track of your final number, because now in this case there was just that one-step math method. However, in the future we'll have work that takes up a little bit more space, and it's easy for your original numbers just to get lost along the way. And while I'm using colors on the screen just for our learning purposes, remember that on the test you only have your pencil. So it is important that you basically figure out a way to separate your information out so it sticks out when you have it when you need it. Okay, so now moving on to the next question. So, I see that. Okay, yeah, so moving on to the next question. So in this case, once again, when each side, so not just one side, right, of a square, we have a shape described, is lengthened by x, or sorry, is with side x, that's the normal length, is lengthened by 3 inches. So each side is growing. Which of the following represents the increase in square inches of the area of the square? Now, a couple of things happening here. One, I'm just going to address the easiest one first, which is the unit. So unit here, they seem to match. All right, because they match and there are no conversions involved, I can just ignore that little bit of info. But always make note, you might have to do conversions at some point. So units will be one of those pieces of info that you actually make a note of. All right, so with that said, now another part. We've been given a figure. And every time you've been given a figure, we need to actually draw it out. Okay? And that is important because as humans, we are very visual creatures. And even if a problem seems complicated, the moment we see it drawn out, it actually becomes easier, and the path on how we're supposed to approach it becomes a lot more obvious. So something could be really daunting when you look at the wording, but then you draw it out and you're like, oh, that's all I want to do? Okay, well, that's easier than they said it. So why don't they just start with that? Something to keep in mind. Now, it says that when each side of a square is length, so we have an original, which is going to be this square, and then we have a change. We have the new square. And the new square is a little bit longer, right? So I'm just going to move this over. Yeah, so the new square is a little bit longer. And we're just going to draw both of them out, and that way we can make the edits, and it's just, let's go from there. So now in this case, we need to pick a number. So that's our very next step in this process. And there we go with the steps again, just so they're there for reference. All right, so replace the variables with numbers. Well, we have only the one variable, and we don't actually seem to have any criteria here. There's nothing here to tell us that we need to stick within certain boundaries, or it has to be greater than a certain number, nothing like that. So we just plug in anything. And like we talked about before, best number to plug in to keep math simple, 2. All right, so now that we know that if each side is 2, so let's just draw that out, and it's lengthened by 3 inches. So each side is lengthened by 3 inches, right? So this is going to be 5. Then which of the following represents the increase in the area? Okay, well, we have to find the area. Now, area formula for a square is going to be length times width, or base times height, whichever version you prefer. It's the same thing, right? And that's going to be 2 times 2, which is 4. Okay, and then the new area over here, following the same premise. So area is going to be basically 5 times 5, and that will be 25. All right, and now to actually, so we followed through with the math, right? Let's just check things off our list. This one, we followed through. We need to find what our final answer is because the question is asking us about the increase, not the area, but the increase. So to go from 4 to 25, what did we increase by? Well, we increased by 21, right? Because 25 minus 4, so we went up by 21. And that is going to be our final answer. Now, let's circle our x value as well. And now to put that into practice. So now that we have our final answer, check all answer choices. Here's what that means. So now we plug in our x value for every time we see x down this row. So this is 4 plus 6 is 10. And this is when the final answer becomes relevant because this is 10. We need it to be 21. All right, so A is out. Then here we have 2 plus 3 squared. That's 5 squared, which is 25. Still not 21. Now notice what would have happened if you hadn't been paying attention to the problem and we just thought, oh, well, what does increase mean? Or we just overlooked the word increase and we just got excited that we figured out that 25, then you would have picked B. So the wrong answer, the most obvious wrong answer, will always be in the answer choices. Now, these test makers are not trying to be your friends, so it's very important to basically double check your work and take it a little bit slowly. I know it's a timed test, but just go just fast enough that you're not rushing. You're just being very cautious and taking into account every part of the problem. That's why we mark up the question. All right, then moving on to the next one. 6 times 2 plus 9. 12 plus 9, that does give us 21, right? So we're going to leave that alone because remember, we have to check all answer choices, not just find the right answer and move on. Because again, we could have picked that combo or the x value that validates multiple answer choices. So let's just finish this out. 6 plus 2, that's 8. Okay, that's definitely out. So our final answer is C. We move on. Again, this might seem a little slow. That's only because we're learning it and I'm moving slowly to explain the process, but as you practice this, your instincts are going to build. So yes, the homework might take you a while, but again, don't freak out over it. Just give yourself that time, and you'll be fine. Okay? So with that said, let's just clear and move on to the next slide. All right, so now we have this particular problem, which is that if y is greater than 5, so that's our first key piece of info, then which of the following is equivalent to that equation? Okay, cool. Once again, we have our steps. So replace the variable with numbers. Okay, well, we have a little bit of a criteria, but nothing crazy. So we want to replace it with the next best thing, 6. Okay, so now let's pretend the 6 has always been there, and we go with step number 2, which is completing the arithmetic. Okay, well, let's just put my window down here. Okay, so now let's complete with the arithmetic. So let's do 1 over 6 minus 4 plus 1 over, 6 minus 3 And yes, on the test, I would be that lazy. I'm not about to pull out my eraser to fix that. Okay, then we have, this is 1 over 2 plus 1 over 3. Okay, and now at this point, we are not even really in algebra mode anymore. We're just adding fractions. So if you might recall, the rule for adding fractions, and this is part of a future lesson, so don't worry if you don't remember it or if you need a recap, but the rule for adding and subtracting fractions, I'm just going to shrink that a little because I need a little more workspace. But the rule is that you should have a common denominator. So we need to make sure that we have a common denominator. Let's ignore this one up top for now, meaning we're going to just carry it over. And what is the common denominator between 2 and 3? Well, you're looking for multiple, looking for the least common multiple. And the least common multiple is 6. So in order to get to 6, we end up multiplying this side by 3 over 3 and this side by 2 over 2. Really, we just crisscross the denominators. You might notice that. Okay, then it's just 3 over 6 plus 2 over 6, and that then carries us forward to the next step, and that's just going to be 1 over, color coding is fun, but it takes a little bit out of you. Okay, so now that we have this fraction, now we're at the multiplication and division of fraction stage. And for this step, this is basically keep, change, flip. What does that mean? Well, you keep the numerator, which is that. You keep it as it is. So because we're dealing with fractions, I'm actually going to put it 1 over 1. Then we change the sign. So it says division with this fraction bar. We're going to multiply. We're flipping it, or we're changing the sign, right? From division to multiplication. And we flip the denominator. This is 5 over 6. We're going to make that 6 over 5. So our final answer, I'm going to box that in red, just so we have that sticking out for us, is going to be 6 over 5. So now when we plug in 5 for all of these, we need our final output to be 6 over 5. All right? Okay, now here's another thing. Logic indicates that if I plug in a whole number in these areas, in A and B, I can't get a fraction. I mean, no matter what we do to it, I can end up in a negative number situation, but we're only dealing with whole numbers here, so I can't end up with a fraction. I hope that makes sense. And if not, then just go ahead and plug it in, have it play out. But you're allowed to use logic to shorten your math and life out on this, right? So a whole number is not going to lead you to a fraction when we have no other fractions it's happening to, so A and B are out. Now notice, and this is unique to this particular problem, it's not going to happen every single time, but in this particular problem, C and D are just flipped. So really, we only have to try out one of them. We only need just one of them to work, and then we can move on. So in this case, we actually don't have to check every single answer choice because it's going to be either or. Right? Okay, so let's just try out C and go with it. So we have 5 or 6. Wow, I meant 6. Sorry, I probably should have corrected that. I saw the 5 up here and I made a mistake because I did not highlight my variable. So let's try that again. Okay, so 6 squared minus 7 times 6 plus 12 all over 2 times 6 minus 7. All right, so now in this case, I'm gonna erase a little bit. Why? That's not erasing it. But I'm gonna erase a little bit just for space. I'm not gonna erase our final value because that's way too important. We need that on the screen. So we have a 36 minus 42 plus 12 over negative. This is what? 12 minus 7. Okay, cool. So now just moving that down here and breaking it up into more steps. So let's just deal with the first two. And here we get negative 6, right? 36 minus 42 plus 12 over negative 5. I mean, this one's looking more and more like it could be it. Or sorry, positive 5. And then that way we get positive 6 over positive 5. And that is what it spits out, which means this one would have been 5 over 6, the reverse, because then they're flipped, right? So C is the answer. Right. I hope that helped. You can always pause the video if you got lost in the work or you just need to write things down. All right, so moving to the final question that we'll be reviewing together. And like I said, don't worry if you have questions, then You're going to have a homework to practice, but always feel free to show up and take advantage of office hours. We'll happily walk you through any problem, or guide you through, not just fully walk you through, but I will guide you through any problem that we need to go over. So please don't hesitate. Take advantage of that. That is part of this course. So take advantage, show up. All right, so with that said, number 4. Now, as we said, number 4 is a little bit different because we don't have an original number. So now taking a little bit slowly, I know we read through this before, so let's just take it a little bit slowly, make sure we have all the key pieces of info that we need. Okay, so in this case, we have that Anna spilled 1/3 of her M&Ms. That is information that we need to mark down. So 1/3 of our M&Ms, and we're just going to go ahead and circle the brackets. Oh, right, we need the steps. And then we're just going to go ahead and circle the 1/3. And then Joey ate 1/5 of what was left. Then he gave the M&Ms to, Joey then gave the M&Ms to Cody. So whatever was left from that balance of the 1/5, after 1/5 was eaten, rather, he gave it to them, who each ate half of what remained. It's important because notice they threw in a subtle fraction in there by using words instead of the normal numbers that we're used to looking for, right? So what fractional part of the M&Ms did Cody eat? All right, so remember, what is the question asking? Asking for that Cody ate. So Cody was the one who ate half of what remained. All right, cool. So I noticed sometimes when we're marking work down, it gets a little messy, but I still was able, because this is my marking system, I'm playing around with circles, I'm playing around with underlining. You can box, whatever your method is, right? But it helps me keep track of the information. So this is something you personalize. Don't worry about trying to stick to the same method I do. Notice I also circle back, even if I underline the question, found here. There's no one way of doing it. The whole point, again, is what information do I need to stick out to me? What do I really need to understand to answer this question? Right? Okay, so with that said, let's get started. Now, when we're trying to pick our own numbers, so we have 1/3, 1/5, and 1/2. Again, going back to when we're replacing, in this case, we're not going to be replacing, we're going to be picking an original number, but we need to pick a least common multiple, just like we did with that previous problem with the 6 and with the 2 and 3, we picked 6. Same idea here. One of the easiest ways to do it is just multiply the denominators together, and really we're not actually doing this in a fraction form, but it's just multiplying these together. So 30 is a good number to plug in, okay? Because 3 times 5 is 15, times 2 is 30. So 30 is a good number to plug in, and then with that said, we're going to continue moving forward with the problem. So now that we have our original number, which is going to be 30, so we started with 30 M&Ms, and I know no one's really counting M&Ms. Or maybe you do. I don't know. That could be your hobby. Before you eat them, you count them, or you sort them by color, which I occasionally did, but with Skittles, not M&Ms. Anyway, so we started with 30 M&Ms, right? That was the original number. Now, Anna spilled 1/3. So what is 1/3 of 30? Well, to do that, we're just going to put this 1 times 1/3. And however you prefer to do that when dealing with fractions, you could cross out here, and then because they're both divisible by 3, this goes in 1 time, this goes in 10 times, so we're left with just 10. So 30, or 1/3 of 30 is 10, so she spilled 10. And we're left with 20. Okay, so after she spilled 10, what happened? Well, after that, Joey ate 1/5 of what was left. Okay, so that means what was left was the 20, and we need 1/5 of that. So we're going to do the same thing we did before. So 20 over 1 times 1/5, and you might prefer to do the canceling out method, or you might prefer to multiply across and then divide, whichever approach you prefer. Usually I recommend this version just because you have smaller numbers to deal with. Here, these could get chunky, and then you end up with a huge number here that you then have to deal with. So whichever you prefer, honestly. Okay, so this one, so Joey now ate 1/5. Let's put this as Joey. This was Anna. And we're left with 16. Okay, cool. And now we have Sadie and Cody, who each ate half of what remained. So what remained? 16. Well, half of that, that's just 8. So they both ate 8 M&Ms. And that means we have Sadie's here and Cody is here, right? So what's the question asking? Always going back to what the question's asking. What fractional part of Anna's M&Ms did Cody eat? Well, Cody ate 8 out of, so part over whole, right? So part was 8 out of the original 30. And that needs to be reduced. Well, what number goes into both of them? We can divide them by 2, which would then give us 4 over 15. And that is one of our answer choices. All done. All right, so this is what the plugging in strategy is. We saw a couple of different types of problems. Now, with this said, I do want to emphasize that this is not the end-all be-all of all plugging in problems, which means you're going to see a bit more of a variety. And some of those varieties are actually included in your homework. However, I purposely, and this is going to be a common theme for all of the homework, which is I'll include maybe about 80% of what you might see on the test. And that means that, if we have a certain concept like exponents or plugging in, I'll include some of the most common ways you'll see it. However, because I want you to build your reasoning skills, not memorization skills, because if you end up just memorizing what the problem's going to look like and how to approach it, great, but that's not going to prepare you for being blindsided by something completely different, right? So because of that, I'm leaving a little bit wiggle room and actually not giving you every single type of problem you might see because I want you to build your reasoning skills. Now, with that said, you will still see them in the course. They will just be part of your drills and they will be part of your mock exams. So it's not that you're just completely left out and you're not going to see this at all. No. They just intentionally will not be included as a part of your homework, just so you build on those reasoning skills that are necessary to navigate this test. And that way, if the test throws a curveball at you in any way, shape, or form, you feel confident in sticking with the strategies that you have learned, that we've covered. And as intimidating as it might look, you get better and better at just breaking it down into something that's decipherable, that you can work with. All right, so it is intentionally like that. So even in the drills, when you happen to see a plugging in problem and maybe you come to office hours and I say, oh yeah, that's a plugging in problem, and it just doesn't look familiar to you because you didn't see it as a part of your homework and we didn't do that in practice, that was fully intentional. And I know, and because I went through multiple different prep books, I went through all the different exams. It was all intentional. It wasn't just something I happened to overlook. So with that said, now getting to the homework portion of it. Homework will be posted in a separate link, but just to give you an idea of what's coming up. So you do have a plugging in worksheet, and that's going to include about 30 problems, and the answer key is always included, as we've covered before. And then your other homework is going to be in exam 1 of the Princeton Review Book. So just as a heads up that in the Princeton Review Book, you have a pattern of gray, white, gray, white, gray, white, gray, white, right? Here's my book. So in this pattern of gray, white, gray, white, gray, white, all the grays are full-length exams, and all the whites in between are answers with explanations. So because this book consists of 10 practice tests, we actually have 10 section 1s, 10 section 2s, 10 section 3s, and 10 section 4s. So we have 10 reading sections, 10 grammar, 10 no calc math, and 10 calc math, right? And your homework is going to be to go to exam 1, which is the first gray section, jump to sections 3 and 4 and identify and complete all of the plugging in problems. So the purpose of this exercise is so you can sort of figure out plugging in problems in their natural habitat, right? You are now reading through all of these different concepts and you have to figure out, okay, well, which one's going to require plugging in? Really, you might have maybe 2 problems. You might have 3 problems. You might have 4 problems. It just varies by section, by test. So look, that's where your identifiers come in. Make sure you keep them in mind, and obviously you have the notes in front of you, so don't worry about fully memorizing it right now. Now with that homework, so with the stuff that's in the book, because it's so spread out, you do not need to submit photos of these questions. However, you will need to tell me what question numbers you picked. So if you saw, exam in section 3, I found that number 2 is actually plugging in, and number 15 is also plugging in. Okay, then that's what you're going to write in. So you don't have to take pictures, and obviously come to office hours for help if we need to go over any of these questions. I cannot emphasize enough that come to office hours, come to office hours, come to office hours. I am there to help you, and it is one of the best parts. So that's pretty much kind of sums up what our homework is and what the entire plugging in concept is. It will take practice. It is going to feel uncomfortable, but like I said at the beginning of the video, just bear with it, use the strategy, even in situations when it seems like doing it the algebraic way would be faster. Don't. Just for the sake of this, use the strategy. All right? Okay, so with that said, good luck on this assignment. Again, taking advantage of office hours, and I really look forward to seeing you there. And I will see you in our next lesson. Bye.